Hello YouTubers, today we see the basic linear regression algorithm implementation in TensorFlow. So, the basic linear regression is a technique that measures the relationship between two variables. So, in simple words, what we can do, here is some data points. What we need a single line which can represent the whole data set. Okay, so how we can achieve that? So first we need a line. So our equation is the simple line equation, and then we need to find out on what cost we need to design that line. Means we need to reduce the mean square error of that line with all the data points here. So here is our cost function. So let's start how we can implement that algorithm in TensorFlow. So first we need to import the header files. Then what I do that create a random data set by using numpy array and take the shape of that numpy array and samples. Now I can plot this data point in scatter plot. Okay, now as you see in this equation we need two variables w and b, whereas x and y is the input and output. So let's define two TensorFlow variable w and b, where w means weight and b is bias. And here as you see x and y is the input variables or output variables. So in TensorFlow we take input and output variable as a placeholder. So I define two placeholder, one for input, other for output. Now this is my equation. Prediction is equal to weight multiplication with input plus bias. So I can implement this equation in TensorFlow like this. TF dot multiplication is calculating the multiplication between x and w, and then I add the output of this TF dot multiplication with bias b. So now we need to implement this cost function. So the cost function linear regression is a simple mean squared error. So the equation of this mean squared error is something like this: predicted output minus expected output whole square sum plus k to n divided by 2 multiplication of number of samples, whereas n is also the number of samples. So this is the equation in TensorFlow, where first we need to subtract the predicted output minus expected output, the power 2. So TF dot power is just give the predicted minus y to the power 2. Then what this do just the summation of all the terms in the matrix. Actually the prediction is also a tensor. This prediction variable is a tensor, or we can say matrix, and y is also a matrix. So what TF dot reduce sum do, it is a TensorFlow function. What it do, it just sum all the variable and reduce it into a single dimension if it doesn't provide any dimension explicitly. So as you see our equation something like this. So if suppose here is the this equation, if suppose predicted minus expected is something like this, then our TF dot underscore reduce sum is equal to 6, means it will reduce the whole dimension in a single unit. So it's sum up which is similar like a summation. Then what you do, the output of this predicted summation of predicted minus expected whole square divided by 2 multiplication of number of samples. It is simple mean square error. Now we need to set a learning rate. So I can give you the parameter learning rate. Then we use the simple gradient descent optimizer, in which I pass my cost and learning rate. What it do, that it will minimize my cost function. It is simple gradient descent function which minimize my cost function by optimizing the value of weight and bias. So what it do, it will try to increase or decrease weight and bias so that my error get reduced. Error means cost get reduced. Simple. And then we need to initialize the whole variable. Whole variable means in this algorithm we need just two variables, weight and bias. So what it do, it will just initialize the variable. So I will just define number of epochs and display step. What display step do is the printing the parameter after certain steps. So display step, it means 50 means after 50 steps I can outputting my variables. So in TensorFlow, for running any program, we need to first define a session. Every equation calculated in TensorFlow within a session. So we define a session like this. And launch the graph means in TensorFlow every calculation is calculated under a graph. As you see, I never define any graph here because I am using default graph. Whenever we start running TensorFlow and doesn't define any graph, TensorFlow using default graph. So we need we first initialize this session, then I pass init this variable into session.run. Before using any variable we need to initialize. So I am passing this in my first line of the session. Then I write a simple we need to write a simple for loop equation which just fetch each and every input and output set and just pass my optimizer. And here is one thing you see, that feed dictionary. What feed dictionary do is just take the value of placeholders. As I earlier said, x and y is my input and output, and that input output comes from numpy array. So this training underscore x and training underscore y is not a tensor, it is a simple numpy array. For converting that numpy array into tensor or inputting any numpy array or any TensorFlow outside data structure into a TensorFlow, we need the placeholders. So placeholder is just a simple read and write. It's a kind of inputting data inside a TensorFlow from outside the TensorFlow. So I pass this feed dictionary x and y and their respective values, that is numpy. So what it does, it just call this optimizer, and after each epoch it optimize the variables. So in this equation we have only two variables, that is weight and bias. So after each epoch it will update the weight and bias so that my error get reduced. So we need to see how error is reduced, and after each epoch how many we need to display the parameters after each display step. So for that, what I do just write a print. We need to run another function, that is cost function, and inputting the same training x and training y data. Then I can display it like this. I run the session.run and pass the weight, and the session.run pass bias, and it should display me like this. And then after optimization finish, we need to calculate the final cost. Final cost means final error, what I get. So here we calculate this by writing simple session run, passing the cost function, this cost function. Now this cost function doesn't change w and b because it is not optimizer. It will just feed passing this training x and training y into my cost function, and just calculate the simple value of cost function. Now I can plot it to visualize how my line is fitted. Let it run. Okay, first I need to forget to now see. Okay, I think there is some now you see after each 50 epochs it will display my cost, and cost is reducing. You see each epoch cost is reducing, and this is my final training cost and weights and bias, and this is my plots. So guys, this is a simple linear regression implementation in TensorFlow. Hope you like it, and please do like and subscribe my channel. So for this video, thank you.